Hey there! Thanks for joining in for this video. Today I'll be showing you how to create this interesting effect, which I use to create this pretty awesome self-portrait, but which can be applied to really any piece of geometry that you want. So if that sounds interesting to you, let's send it! Rolling.
All right, so here we are in Houdini. Let's jump into this node and see what's going on. So the basic workflow for creating this effect is I've taken a piece of geometry, which in this case is a 3D scan of myself. If you could use photogrammetry or hand model or whatever method you want to create this source geometry. I'll also show you a way to get this interesting kind of fracturing a little bit later in the video. This is just due to the fact that the scan wasn't that great, but I thought it was a interesting kind of design feature actually in this case. And so what we do is use this geometry as a pyro source. So this is kind of continuing my experiments using the pyro solver and what we can do with it in Houdini. And so I make this pyro source by just scattering points on it using the pyro source node. And then I use a wrangle just to set a velocity that's pointing backwards. And we can preview this by clicking the I, then clicking on V. So you can see we have this just straight backwards velocity. And that gets turned into a volume and ran through the pyro solver. I won't click that because I don't want to recook the sim, but let's take a look at the cache here. So we get smoke simulation like this, and so it's not looking like too much right now, but what we can do is actually run this through some VDB conversion tools. And so for those of you who aren't familiar with VDBs or working with VDBs in Houdini, it's one of the coolest workflows, I think, that is in this software. Essentially, you can go from these volumetric representations of volumes, this fog-like representation, and convert it to a surface-like representation or an SDF. And that SDF can then be turned into actual geometry. And this workflow can be applied in either direction. You can go from volumes to solids or solids to volumes, and it's a really neat way of working in Houdini for a lot of different cases. So in this case, I've converted the native Houdini volume to a VDB, just a fog VDB. So this isn't changing the look of anything, it's just more of an optimization step. And then I delete everything from the simulation that's not density, because that is all I'll be using in this case. I just clean it up and remove all the miscellaneous attributes so we don't have that much data. And I'll get into this structure in a second actually. So if I look at this tree, it's exactly the same up to that point. And so then you can convert this VDB to an SDF VDB. So this is just shorthand for sign distance field, and it's a way of representing, you could think of it as almost the surface of that fog volume. And so if you lay down a convert VDB node, and you just set this to VDB and change the class to convert fog to SDF, that's what's happening here. And that transforms this fog volume into something like this, which is pretty interesting. So you get almost like this mushrooming type effect that, you know, some people might not find desirable in pyrosims, but I think it creates this very interesting, weird, amorphous, organic growth-like structures in this model. And so then you can go ahead and run this SDF through some smoothing operations. So here I use a VDB reshape, set to dilate to just boost up the width. You could think of it as kind of just like a peak node does to geometry. This is pushing the voxels outward. So if I ramp this up a bit, you can see what's happening. It's kind of ballooning upward. Very nice. If you need to get an effect of someone getting stung by a bunch of bees or something like that, that's a good way of doing it. The aftermath of a bee sting. And then the reason I'm using this reshape is simply to balloon it outwards a little bit, because this VDB smooth operation tends to erode it back down. So this reshape is compensating for this smoothing operation. So if I toggle this on and off, you can see kind of the effect that's happening. It's just making sure we don't lose too much data. And you can really adjust the smoothing here and the dilation value to get different effects on this SDF. And so when you're happy with how that result is looking, you can use another convert VDB node to convert it back to polygons. And so now this is just a completely polygonal mesh, but we have this interesting animation and geometry getting generated from the pyro sim. And I originally had seen this type of workflow in one of John Koons's live streams, and I can dig that up and put a link in the comments too. And once we have this, we can really do anything we want shading wise and geometry wise to create an interesting final render. So let me show you how I might do this or apply this just to any other type of geometry. So let's see how this looks with the pig head, for instance. So if you have something like this, let me make it roughly the same size as my 3D scan. It looks like it's pretty good. I'll go ahead and just transform it into about the same position so that I don't have to fiddle with the pyro simulation. So here's our pig head. And go ahead and just center that on X. And I'm going to change the pig head to easy, just so it's a simpler geometry. And I will subdivide this to get a little more resolution and smoothness on it. And maybe I'll up this, because let's say I want to get this kind of weird look, like this kind of cutout look. There's a lot of ways to do that, but let's try attribute noise float. So I'm just going to use a noise to delete parts of this so we get kind of a similar look to this bust scan. So let's go for noise as the attribute name and click on I to preview this. And we will set this to set positive and turn on our visualizer so we can see what's going on by clicking this little button here. And let's adjust the size of the noise. And you could do this in a point VOP to get more control, but just for sake of time and demoing, I'm going to do it this way. And then maybe let's do something like add a blast node and use a simple expression. I'm going to untemplate my head over here to blast, maybe if that noise attribute we just created is less than 0.5. So now we start getting this kind of cutout look similar to the bust. But what I kind of like about how this looks is that we have a solid front and then it kind of tapers off to the back. So let's let's use a point VOP to modify this noise. So I'll put down a point VOP here. Maybe call this noise mod. And let's dive in here and bind in our noise that we just created. And we'll export it back to the noise by just typing in noise. So it looks exactly the same, but now let's see if we can do something like this. Add a relative to bounding box, which gives you a gradient from 0 to 1 based on the object's bounding box. So if we're looking here on Z, for instance, values over here would be around 0, and then values over on this side would be around 1. And so we can use that to fade off this noise in a nice way. So let's try that. I'm going to convert this vector to a float because by default this gives you X, Y, and Z. So I just want to isolate the Z here, which is the third value. And let's multiply that across our noise and just see what happens. So something's happening. Let us add a fit range here so we can see this a little better and clamp this noise. So if I start bringing up this low end of the noise, you can see I can essentially make a mask here. So I'm going to push the 0 up a bit, maybe here, and then pull this down. So we get something like this. And that looks fine to me. You could tweak this all you want and do different noises to get this effect, but just as an example. And so instead of blasting noise less than 5, I'm going to blast noise greater than 5. And if I go back to my point VOP here, maybe I want that noise to affect a little bit more. So I'll bring that down and maybe bring this down. And yeah, that seems fine. And of course you could go into here and manually select some places to delete as well. But this is just showing another option of how you might go about this. And so let's go ahead and try this for the pyro source. And maybe I will just blast some of these faces back here. Delete. We don't have to be too precious about this because the pyro is going to do most of the work for us. Yeah, let's try that. All right, so let's go ahead and just copy paste this series. Maybe I'll just recreate it actually, just for demo purposes. So we start with this pyro source node. So I'll go ahead and lay that down. And we want to create a attribute for density and an attribute for temperature. And if you watched my wonky fire tube tutorial, this is basically gone into way more depth in that one. So I'll link that in the description, and you can check that out if you want more information on this pyro workflow. So we'll do surface scatter to get some points all over this pig head. So now we have a lot of points on top of the pig. And now we can create the velocity. So this is a little bit of vex. If you don't like vex, you can set this just with an attribute create. So this little snippet of code here is the same as if I did attribute create and set this to V and then set the value, let's see what I set it as, to 1 on Z. So I can just set that to 1 there. And so that is exactly the same as this little snippet. Sometimes I just find myself using wrangles as it's easier for me to know a line of vex than what node does what sometimes. Anyway, let's go ahead and do the rasterization of these attributes. I'm going to set my mode to manual because I have this at fairly high res so I don't keep cooking. And let's set this to a lower res just for demo purposes. And let's grab our pyro solver as well. This is just a standard pyro solver. Refer to wonky tube if you want more details. And let's set this voxel size a bit higher for demo purposes as well. So just 0.1 and 0.1. We'll see how that looks. Got some warnings here. All right, so we have the pig head, the volume solver, and let's see how that looks. Looks nice. And then let's go ahead and run this through the same conversion process. So I'm just going to copy paste this whole chunk here. Should have kept it on manual because now it's cooking. I just canceled that. So I'm going to take all of this here, just copy paste, and let's see how that looks here. And if you want to organize nodes like that, if you hold down A and then drag in certain directions, you can quickly organize your nodes. Hot tip. All right, so let's see what we got here. So there we go. We got, it's much blobbier, but you can see we're doing the same thing where we convert to the surface, smooth it, and do all those operations. And if we wanted it to be more detailed, we would need to lower our voxel size. So let's try to crank this a little bit here. Dun, dun, dun. Cooking. I could fast forward this, but maybe I'll let you all suffer with me. Almost there. Getting close. All right, I'll cancel it there and go to frame like 35. So it doesn't take... This is where I get impatient. I should have just let it cook because now we're re-cooking again, but... Here we are. And there we go. So this has, you see, a lot more detail by lowering the voxel count, and we're getting that same sort of interesting mushroomy behavior, which is often undesirable, but I think it looks pretty cool for this case. We convert it to just a regular VDB, and then we convert it to the SDF, and then you see we're getting this type of interesting amorphous type of geo. It's actually really cool. I don't know why I like this type of effect so much, but it's actually like pretty straightforward, but you get a lot of good details from the pyrosim. And if you wanted to capture more fine detail or less fine detail, that can be tuned in when you convert to SDF. So on this SDF conversion node, this fog ISO value kind of lets you clamp or almost expand or contract where you want that surface to be in that smoke sim. So let's say we set this lower to like 0.1, you can see it kind of inflated it. And then if we set this higher to like 0.9, it goes a little bit down, but we're not really getting that drastic of a change in this case, just because the smoke sim isn't that detailed, I think. But if you, for instance, let's go back over here and look at the my face simulation. I'll go over to here. It'll just take a second to cook. So if I go to the convert SDF here and I set the ISO value way down, you can see we get kind of this more balloony type of smoke. And then if I set it way up, we start to get, we lose a bit of detail here because we're pushing it too hard, but you'll start like cutting into the volume. So that's another way to kind of control how to isolate or how to convert that fog VDB into a surface or SDF. Okay, and then so the one other thing I wanted to point out in this whole setup is how I dissolved it at the end, which is a kind of a neat technique, I think. So let's go over to this left side, which is where I'm doing that kind of fisheye dissolving shot. So it's exactly the same where all that we're doing here is converting the volume to a VDB, the fog volume here. And then I'm using a volume VOP to chisel away at this, this volume. So over time, I'm animating an offset that chunks out bits of this fog before converting it into an SDF. So if I let that cook for a second, you can see I'm basing this on the Y height, and I'm just fading off the volume in an interesting way. So let's find a cool frame here, maybe 100. And you can see this is taking a while to cook because this is a very high res volume. Let's look. So we're at pretty high res, 36 million. You'd want to keep your voxel count a little lower when you're developing this, and then raise it up for the final simulation. And so if we convert this to an SDF after chunking out bits of the volume, you can see we can start carving into the SDF, which creates this interesting look where you get this interior cut in to that surface. So let's look at how to do that on the pig head just for demo purposes. So I'm going to create let's go back over here to our simple pig head setup. Dun, 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 dun. And this, you would definitely want to cache this out before doing this volume VOP operation. It's just cooking right now. Maybe I'll fast forward this if I get really ambitious in the edit. Okay, so here we have the cool pig head smoke, which looks cool as a smoke simulation actually as well. And so we convert that to the regular VDB. And right here, after we clean it up and before we convert it to the sign distance field or the SDF, we want to put a volume VOP. And so what volume VOPs are is essentially the same as a point VOP or an attribute VOP, but it works on volume. So you can do a lot with this. So essentially what I'm doing is similarly to how I created that ramp from the bounding box just to make some noise on the pig head, we can do that, but on the Y-axis on the volume. So let's see how to do that. We can still use this relative to bounding box node and pipe in the position. And we'll go ahead and transform that to float to vector again, or sorry, vector to float, to isolate the Y value. So let's just pipe that, or actually let's just multiply that by our current density to see what happens. Boom, boom. And it's a subtle change in this case, but you can see, you can kind of tell that this smoke down here is less dense than this smoke up here. And so let's fit range this to really accentuate this. All right, so let's maybe pump this bottom value up. So you can see I'm cutting into this smoke here as I raise this value. So that is pretty neat. So what I can do to make this more of a thin cut, let's make a parameter so we can control this. And we'll call this, I don't know, let's say dissolve. And label is dissolve. And so now if I jump up a level, I have this nice little control for dissolving the pig head. So if I bump this up, we can just have it fade off from bottom to top. And to make this more of a sharper fade, for the source max, I'll just make that a little bit bigger value than my source min, and that'll create more of a sharp line. So I'll go ahead and add that there, and you can see now it's the same value, so it's this super sharp cut. And I'll add a constant here to the add node, and this is like the feathering of the dissolve. So let's add like a 0.1. And so now we have this little bit of a smoother gradient. And you could technically make this a parameter for another person to control that fade off there, that line. And so that's pretty nice. Now we can animate this dissolve parameter and simply cut our volume. And so you could animate this with keyframes, with an expression, whatever. And then when you convert this to the SDF, it will only convert the bits that aren't zero density. So you get this cool cutting of the geometry as you animate this. So I can just kind of move it around here so you can see what's going on. And the one other thing I did in this case is this is pretty neat, but it's not that interesting to have this like completely linear straight line here. So what we can do is go back into this volume VOP and add a little noise to the position to vary this this cut across the pig's head. So let's go ahead and do that. So this is a pretty common way of distorting the position of your incoming geometry, and this could be done in a point VOP as well. The same type of concept on a regular piece of geometry. So let's add a anti-alias flow noise, and I'll set this to a 3D noise because we want it to affect the X, the Y, and the Z. And I'll pipe in P to P, and then when we add this before this relative bounding box node, I'll just add it to the position. Let's see what happens. And now we're getting automatically this nice kind of organic chipping away. And you can raise the amplitude of this noise if you really wanted to emphasize this. So now we're getting this really interesting shape, and if I go to the polygonal version of it, you can see what's happening. So now we have this chunking away, and so we can still animate this. So I'll set this back to 0, and this is it'll take a second to update because we're dealing with a decent amount of geometry. And you can see if I start raising this, we'll start cutting up on the y-axis into the model. So that's pretty awesome. And you could, if you wanted to, you could apply this to any axis, for instance. So, whoops, didn't mean to do that. Let's delete this edit node. It's starting to chug a little bit. So let's go over here just for the sake of demo. I could just change this, for instance, to the z-axis, and then we would get this same dissolve happening across the z. And maybe it would be more interesting to invert this for the z so it dissolves from the back. So let's see how that looks. If I just invert this fit node, so destination min is 1, max is 0, we could start dissolving from the back side towards the front. And you can see that happening if I increase our dissolve slider. And then if I decrease it, since it's reverse 0 would be dissolving more. And so you can see we're now chunking away from the back to the front. So that's a pretty interesting way of working and dealing with geometry. You're essentially just taking a a solid piece of geometry here, making it a pyro source, then converting that pyro source to a VDB. And really all that means is you can see these are just Houdini volumes, and so they have more voxels, 51 million. And when you convert it to VDB, it's just an optimization, so it decreases the amount of voxels. So now you can see density as 23 million, because VDBs don't have to fit voxels in this entire bounding box. They can just have voxels where there's actual density. So that's just an optimization step. Then you can do whatever you want to that volume and then convert it to an SDF, which is more of this surface representation of a volume, and then do whatever you want to the SDF with these reshaped nodes, and then convert it back to polygons. And so that's how you can get this effect. I feel like I keep saying this. I guess it's fairly straightforward, but you can see we're not dealing with a ton of nodes here to create this interesting type of animation. So that's, I think, going to be it for this one. I'll mention briefly this was rendered in Solaris, and I used all procedural materials. I might make a follow-up video on that if you're interested in some of the how I would go about procedurally shading something like this, because it's a little different since we have a constantly changing geometry. It's a little tricky. You have to use some procedural shading techniques to actually create a material for something like this. If you're interested, let me know in the comments. And if not, then maybe I'll do something else. Anyway, thanks for tuning in and have a great day.